Here we go. It's coming.
There it goes.
Now, does that work?
Yes.
Okay, all right. Apologies, everybody, for the delay here. My name's Chris Goodall. Thank you very much indeed for inviting me to your Transition Buxton session. We've got a short amount of time. I'm going to compress what's in that book in an effort to just explain a little bit about the areas where I think the UK, it's specifically about the UK, could move in order to get to net zero within 20 or 30 years. A difficult task, but it's something that increasingly is seen as important. I'm going to talk until about 5 to 8, as Robin just indicated, at the latest. Please ask questions, particularly of things that you think are wrong or unclear in this presentation. What the book intended to do was to identify a route to net zero across the UK economy and society. It's not just about decarbonisation of electricity, it's about the 10, 15 areas that we need to work on if we're to move to a genuinely net zero country, fast enough to meet all the objectives that the world has to restrain temperature increases to 1.5 degrees or thereabouts above the pre-industrial level. A tough task. But second, the book is about, and I think this may be more relevant now than when it was published 3 months ago, is about ensuring that all the changes that we make in order to achieve that objective result in net, a redistribution of income in the UK towards the less well-off. It's impossible to imagine a net zero carbon move working effectively if at the same time it increases income inequalities and reduces living standards for the less well-off. So it's meant to give this book a sense that decarbonisation is possible and indeed beneficial for society and particularly for individuals in the bottom half of the income distribution. First of all, I want to stress that the UK has been actually very good indeed, world-class at getting rid of carbon dioxide emissions from the electricity generating sector. We're now down to a fraction of what we were even in 2012, just 8 years ago. We've pushed coal out of the system. We've almost had a month now with no coal-fired power stations generating electricity in the UK, and record amounts of generation from wind, and over the last few weeks from solar as well. Oh my goodness, it's been a good period for solar over the last few weeks. Who knows whether it's connected to reduced pollution, but my personal experience, this has been a record for April and May. But that's not enough. We've got to decarbonise agriculture, aviation, transport of all types, particularly agriculture, particularly ruminant animals, sheep and cows, heavy transport. Fashion is an increasingly important part of our problem. We need to better insulate homes and provide them with low carbon heating. There's the 2 heat pumps there. We need to, importantly and with great difficulty, get rid of emissions from the manufacture of cement. We need to reforest and make sure that those forests capture as much carbon as possible. We need to insulate houses better. We need to make sure that long-distance transport, marine transport, is decarbonised, another one of the most difficult challenges that we face. And we need to make sure that steel and other metal manufacturers manufacture is also moved away from using carbon as a fuel source, or in the case of steel, a source of chemical reduction. Let's have a look at the pattern in the UK for net greenhouse gas emissions for the last 30 years, since 1990, the start of the Kyoto Accord, was about 800 million tonnes a year. That's only emissions, of course, captured in the UK. It excludes imports, which are increasingly important. Things made in China are not recorded in our emission statistics. But that's gone down, and it's gone down quite a lot to around 450, 500 million tonnes in that period. So this is success. That success has principally come from the decarbonisation of electricity production. These figures only go out to 2017. If we took them out to 2020, they would have declined a lot further since, as we've got rid of coal-fired production and moved to more and more renewable energy. But in the case of transport, emissions have barely moved. So I want to stress that while electricity has been handled well, other sectors have seen virtually no decarbonisation. And for the rest of the next 20 years, we're going to have to move towards cutting out the use of fossil fuels in the transport sector, for heating, and thus avoiding the import and use of oil and gas. Now, I want to talk about how we can do this, and we're going to use electricity as the principal mover. So I've said already several times that we've been very good at getting rid of carbon sources of electricity in the UK by international standards. But we can't decarbonise completely at the moment because we have to have enough reserve capacity so that when the wind isn't blowing or the sun isn't shining, we can provide the electricity we need. We can shift electricity a bit, we can store some by batteries, but fundamentally at the moment we can't make electricity consumption exceed our demand. And my plan in this book is to do something which is just being considered now by other countries, which is to radically increase the amount of renewables we have. And when we have a surplus that results from that, we turn that surplus into hydrogen, and we use that hydrogen both as a stored source of energy and as the main progenitor of synthetic fuels, equivalents to fossil fuels that are made from hydrogen and often from captured carbon dioxide as well. This slide here illustrates the problem we've already begun to have, partly as a result of the virus. Electricity demand has fallen by about 25%, which has meant that at some periods over the last few weeks, renewables alone have been enough almost to cover our total electricity demand. And tomorrow, the national grid has been worried that an even lower level of demand as a result of the public holiday might result in high solar penetration, meaning that our electricity production exceeded demand, which is threatening to the operation of the grid. And the national grid has been asking for permission to turn off some renewable generators tomorrow in order to deal with that. But at the moment, this is the way the UK is moving. It's holding down renewable electricity generation in order to make sure that we never have too much, or we very, very rarely have too much. My proposal is that we do something very different. We actually say, look, we can cover most of our energy needs by electricity. We can electrify transport, particularly private cars, of course. We can electrify much heat production, principally through the use of heat pumps, which use electricity to make heat for houses and for office buildings. But I suggest that we need to cover our entire electricity demand by using renewable electricity generation, building 20 times as much as we've got at the moment, which means that almost all of the time, even when the wind is hardly blowing, we've got enough electricity to manage. And we've also got a lot spare, which can be used for the new sources of demand, the electrification of cars and of heating in homes. And we've stored all the surpluses in the form of hydrogen that's generated by electrolysis, that is to say, passing electricity through water to generate hydrogen at one anode and oxygen at the other. Now, I can't go into this in much detail given the small amount of time we have available, I'm sorry, but what I'm assuming is that our surplus electricity goes to make hydrogen, and that's either used to be stored for use in a fuel cell to make electricity from that hydrogen at some point in the future when we don't have enough electricity. It may be used to replace natural gas for central heating. So we run our gas network with hydrogen in the pipes, not natural gas. And it provides the key ingredient for the creation of synthetic fuels. Those are chemically equivalent fuels to the oil and gas we use at the moment, partly by using hydrogen and also by the capture of CO2. With CO2 and hydrogen, we can simply, using well-developed techniques of chemical engineering, make synthetic fuels which are entire substitute for existing fossil fuels. Now, I'm going to dash on a bit here, if I may, just to get to some things that I can handle in the period of time we've got. Happy to send this to anybody that's interested. So let's talk a little bit about making those synthetic fuels, if I may. I'm sorry, forgive me for dotting around here. I'm trying to compress this, and I apologize for the lack of linkage in these slides. This is an illustration of the critical thing here, is of the possibility of using hydrogen for domestic heating. That is to say, running the hydrogen into the domestic heating gas grid and burning it in a central heating boiler. This is the Worcester Bosch, the largest manufacturer of central heating boilers for the UK, equivalent of a natural gas boiler. It's a hydrogen boiler, which sits in the same area and can run on exactly the same system in our central heating for our homes. It's safe, it's no more expensive than a natural gas boiler, and depending on the price of natural gas, it will be equally as efficient, although it may be more expensive. Now, just a bit about making synthetic fuels, which is the crucial thing. There are certain things we can't easily decarbonize, of which the most obvious thing is long-distance aviation. We can't run planes on batteries. We can't run planes on hydrogen directly. What we can do is make equivalents to aviation kerosene from the CO2 from air and from hydrogen. We can also use this to make plastics and other sources of things that we cannot easily decarbonize. How do we get the CO2? Well, we can take it directly from the air. Although CO2 is only a very, very small part of our atmosphere, we can capture it. Here is a CO2 capture plant just outside Zurich in Switzerland. Those are fans over which the air is sucked. The CO2 is captured from the air in that point and then captured by a chemical. The chemical is then taken away and heated. The CO2 comes off, and that CO2 is fed to what you can see in the background, which is a huge commercial greenhouse where the CO2 is then, as it were, eaten by the plants growing in the greenhouse and increases the rate of growth of those plants. This is early stage technology, but it's perfectly possible. Nobody suggests that it is chemically difficult to do. The only problem, it uses a lot of energy. We need cheap energy to do that. But the great thing is, every single month that passes, our energy supply around the world is tending to become cheaper. We've just seen the world's lowest solar power tender in Abu Dhabi for 1.35 US cents per kilowatt hour. Now, very roughly, at home where you are today, you are paying 15 pence per kilowatt hour, 1.35 US cents per kilowatt hour is very roughly 1 pence per kilowatt hour. So you're paying in your home today 15 times what this newest tender in Abu Dhabi has just come in at last week. So electricity is getting cheaper, and it can form the basis of these technologies for generating artificial fuels. We can use hydrogen also to make fertilizer. This is a fertilizer plant in Western Australia, which has got the best resources in the world of renewable energy, where the electricity will eventually be almost as cheap as in Abu Dhabi. This is a plant in northern Sweden, which is beginning to install the capacity to reduce iron ore using hydrogen only, and thus avoiding the use of coal. I'm showing these slides as illustrations of the fact that while we don't often talk about this yet in the UK, hydrogen is capable of replacing most of the things in the world's economic system which cannot be electrified. This is the equivalent for cement. This is a plant in Vancouver, which will actually capture all the carbon dioxide that comes off the chemical process of making cement. And once again, a massive improvement in the way of capturing CO2 from probably the most difficult thing to capture CO2, to capture the carbon dioxide from any industrial process. All right, I'm going to move a bit from energy and other uses of hydrogen to a few of the other things where we're going to have to make massive changes in the way we run our society if we're going to get to net zero by 2040 or 2050 in the UK. Very roughly, around the world, agriculture is responsible for about 50% of all global emissions. Mostly that's not in the form of CO2, it's emissions from methane and emissions from nitrous oxide. These are much more virulent global warming gases. They're produced in much smaller quantities, but agriculture is the main source for these two important pollutants. Of that, roughly 25%, roughly a quarter of global emissions that come from agriculture, most comes from livestock. Cattle, growing of cattle and sheep and other ruminant animals produce about 15% of global emissions. These numbers are debated, but it's roughly that figure. And that comes partly from the fact that cows and sheep produce methane as part of their digestive process, eating grass, but also from the fact that sheep and cattle are normally fed with grain or other foods that are grown on other parts of the world, and the growing of those foodstuffs for animals produce global warming gases. So in order to do something to get to net zero in the UK, we have to get rid of most of the emissions of methane and nitrous oxide from the growing of cattle. Very difficult, socially more possible probably than even was a year ago, but something that's going to pose an enormous problem for us. We need to develop a meat-free culture, or a culture that relies upon artificial meat, which is increasingly available, that doesn't use cows or sheep or other ruminant animals to make. This is a photograph of someone I vastly admire, a man called John Letts, who's growing heritage types of grain as a replacement for all forms of modern grain agriculture. John grows grain in heritage varieties, that is to say, he mixes them. So there's not just one variety in that field that you're seeing him combine harvesting there. It's many different types of cereal, both wheat types, rye, oats, etc. Grown probably seeds that might have been last used commercially 100 to 200 years ago. So they grow 2 meters high. They manage to strangle the weed growth. So there's no need for pesticides or herbicides here. There's no need for pesticides in particular because he's growing hundreds of different varieties one field. So yes, one variety might be lost to an invasion of pests, but in general, these fields are nowhere near as vulnerable to the problems of pests that conventional monoculture farmers have. On the right-hand side is also one huge advantage of this technology, these heritage grains. They grow very deep roots. They can survive droughts that would kill other types of modern agriculture, modern grains. So very briefly, I won't go into this in detail, but look, we need also to do something about clothing, one of the worst pollutants, the least circular of all our economic activities. We use things a few times and we then throw them away. The average number of times a piece of clothing is used in this country has fallen by almost a third in the last 20 years, and the process is continuing. One alternative, for example, is to start making more of our clothes from cellulose, which is much less environmentally destructive and can, if not being recycled, can be easily put back into a production process with minimal environmental consequences. This is a product called Tencel, which is a sort of cellulose product, which I would personally, from personal experience, recommend as an alternative to polyester or cotton. I can't go on a little bit. I'd like to talk about this very, very briefly. I think one of the things that we're learning over the last couple of weeks, last couple of months, is the importance of trying to get cars out of our urban centres. And we need to copy in the UK some of the lessons that have been learned so effectively in Holland. On the right-hand side, that's Utrecht railway station, which has about 35,000 bicycle parking places around it. That's a town of 300,000 people. So almost 12% parking places for the individuals in Utrecht. 50% of the journeys inside the boundaries of Utrecht are either now bicycle or walking. On the right-hand side, Pontevedra in Spain, northwest Spain, is a city which was the first pretty much in Europe to say, actually, we're going to cut cars from the city centre. Nobody ever now says that they should go back. A revived city centre, much lower pollution levels, much lower, of course, carbon dioxide emissions. Right, I've almost come to the end of my time. These are electrified ships. This is what we need to do, and I want to just spend 1 minute on this. The attempts to improve the insulation of our British housing stock have failed in the UK. We still have pretty much the worst insulated housing stock in northwestern Europe. A quarter of our houses were made before 1914, were built before 1914. We have extremely high losses of heat. What we need to do probably is what I call in the book deep refurbishment. That is to say, completely changing the outline, the covering up the outside of most of the houses that we now have in the UK. This is a difficult issue. I realize it in places like Buxton. The older houses are beautiful, improving their insulation to the point where they are up to modern standards, incredibly difficult, but needless to say, we need to do that. Right. The book talks about reforestation. We're the least forested country large country in Western Europe. We need to triple the amount of forest. The reasons for doing that include the fact that we're also the biggest single importer of wood products in the Western world. In fact, the biggest in the world apart from China. Right, I need to finish, but just before finishing, I want to say that in the book, I identify about 10 different ways in which these changes will improve social equity, make better lives for all of us, but particularly the less prosperous. Better insulated homes, better public transport, improved food, lowered pollution, including noise, good quality jobs in renewables, and so on and so forth. There are many benefits that come out of here. We build a better society, and one of the things we're learning at the moment is it may not be quite as difficult to do that as we expect. Thank you very much.
Okay, so Chris, first question, and then I think we'll probably break for the clap. As cement and quarry industries represent roughly 40% of carbon emissions in the Peak District, how long might it take to decarbonise these industries if we adopt the technologies you suggest? And any tips for a small group of volunteers to be effective? Oh, second question.
All right. My watch says it's almost 8 o'clock. I wonder whether we should know.
Yeah, okay. So,
and that gives me also gives me time to think through the answer.
Okay, so everybody, we're going to take about 4-minute break now for us all to go and clap for carers, and see you soon when Chris will return with a great answer to Jean's questions. Chris, are you there?
I am.
Okay. I can see some people are back who were had disappeared for a while. So let's plug on with that first question. Would you like me to repeat it, or are you? Oh,
No. Thank you, Robin. I mean, I'm assuming that the majority of the carbon footprint comes from the use of electricity in some places, but also the use of fossil fuels to power mining trucks and mining processes more generally. Is that correct?
It's well, there's a large cement works near Castleton that uses a considerable amount of energy and produces a significant amount of the 40% of the emissions for the Peak District. Right. And we've got quite a bit of quarrying as well. Yeah.
Okay, so in the case of cement, the only way forward probably is carbon capture of the CO2 coming out of the process of making the cement. And that involves a radical change to production technology. Now, in order to make that happen and for the cement producer to be financially encouraged to make the transition to a zero carbon cement production process, there has almost certainly to either be regulation or a carbon tax. That is to say, if the CO2 continues to be emitted from the cement production process, the producer pays a large amount of money. And very, very roughly, latest estimates are that a carbon tax of around $60 a ton, which is very roughly 3 times what it is at the moment, would be enough to make that happen. But that number will go down. And as I mentioned in the talk, there are now processes which enable a cement producer to make cement without producing carbon dioxide, which goes into the air. So that's number one. Number two is to use synthetic fuels. For those things you cannot electrify, to use synthetic fuels made from CO2 captured from the air, which are neutral in terms of net emissions. Now, we can electrify already a large number of large vehicles that work in quarry type environments, whether they be diggers, whether they be things which move stone or other ores around the place. And all around the world, the process is beginning of taking diesel out of production, out of transport processes. So people, if it's interesting, I'll send some illustrations of companies around the world that are now producing equipment that's electric that would normally be used for diesel in transport. And also details of how to move away from CO2 emissions in cement production. But also, of course, they should be using renewable electricity. And as I understand it, you have at least an opportunity in the dam next to the cement. No, is it cement? No, it's, I'm sorry, forgive me, what the process is. You have sorry, not a dam. You've got a flooded quarry which you can put PV onto next to a quarrying operation or an industrial processing operation. So that would be another step forward there.
Okay. So I have a quite different question that's come in. So change the subject really quickly. Talking about circular economy, do you see potential for 3D printing to make resourcing of spare parts more efficient and so make repairing devices the normal thing to do?
Yeah, and it's happening really quite quickly in certain parts of the world. With the development of the circular economy has been sporadic, intermittent, and hasn't been an easy thing to manage. 3D printing is one of the things that is making it more possible to do that. I'm encouraged also by developments in reuse and repair of electronic devices, and particularly of clothing and other fabrics. But yes, 3D printing is going to make it more easy. There will no doubt be resistance to doing this, and it's not going to work for everything, but it changes a lot of industrial economics in favor of the circular economy.
Pushing on, another question, three actually. How would you change to hydrogen for domestic heating work? Would we need a duplicate grid? And did you say that there would be dual fuel boilers?
Right, I'm sorry, yeah, I had to rush through that. By 2031 at the latest, the British gas grid will be all plastic. And at that point, it will be possible to use hydrogen to completely replace methane, natural gas. It can be done in sections, and the most advanced plan is to put hydrogen into the gas network around the existing natural gas network in the areas around Leeds. It's only a plan at the moment, but it looks as though it's possible. And there are experiments taking place, for example, on the campus of the University of Kiel, moving towards this. At the Worcester-Bosch boiler, which I showed you, is switchable between natural gas and hydrogen. So for the older people among us who remember the process of switching to natural gas away from town gas, it'll be a very simple process, going around just flicking a switch to making sure that everybody is capable of taking and burning safely hydrogen in sections of the grid as time goes on. And Robin, there was a third part to that question. What was it? I've forgotten.
It was, would we need a duplicate grid? Did you say that they would be doing?
No, there won't be a duplicate grid. I think we're running out of time now.
Yeah.
We've got less than a minute.
We've got 35 seconds. So one quick question. What do you think about molten salt, e.g. thorium nuclear energy production? That's a big question.
When we've got solar coming in at 1.35 US cents per kilowatt hour, we have created a technology, we have created an energy technology which is vastly cheaper than any solution, including thorium.
So quickly, in the 5 seconds left, thank you, Chris, very much.